All right. Morning, everyone.
Morning.
Am I audible till the last bench, last seat, everybody? All right. Am I loud? Or am I okay? Or I can be at this volume? All right. Cool. Thank you. So today we are going to talk about CAPTCHA provider impersonation. So this is an interesting technique. May not be very practical, and you may not be able to work it in the wild, but certainly a very interesting concept which you can see and hack around if you have time. So let's get started. I am Gursev, and I work for McAfee Foundational Professional Services. And here is the agenda for today. We are going to look at just one slide on CAPTCHA provider integration, starting with CAPTCHAs. Then we will see how to impersonate CAPTCHA providers. Then there is a tool that comes along, which is called Elipcapcha. We'll have a lot of demonstrations around that. And then will be a couple of recommendations, followed by a Q&A. So I work with the McAfee Foundational Professional Services as a senior principal consultant. I do some stuff. I do security research. I do source code reviews and some other stuff along with that. I have written a lot of tools. Around 4 of them are available. A couple of them are open source, and there are several internal which I wrote, which simplifies and helps my job. So what is a CAPTCHA? I don't think I need to delve more details here. I think everybody here might have seen this. It's just a completely automated public Turing test to tell computers and humans apart. And I think that will be it. It can be visual, audio, or a combination of both. So what is a CAPTCHA provider, and how does it integrate with normal websites? So CAPTCHA provider, why do we need it, and why does it exist? It exists because writing a secure CAPTCHA is very hard. I mean, you write an image, you just generally what it comes down to is you have an image, you have a text on it, you ask somebody to solve that for you. But the OCR engines today are good, and the pre-processing or the CAPTCHA pre-processing can be done in a very efficient manner that can help you solve the CAPTCHAs, which are like more solvable by machines than humans. So writing secure CAPTCHAs is hard today because of the advancement in the digital signal processing and image processing algorithms. Then the CAPTCHA providers, for that purpose, we have CAPTCHA providers, which what they do is they provide you a secure CAPTCHA implementation that you can incorporate in your web application or any type of application you want. Either it can be image-based or audio-based. So it offers CAPTCHA generation and verification capabilities. So it does generation for you and also does the verification part for you. And the websites can consume these services. So you have an API, you create your login with those guys, you have an API which you can include in your code, and you can consume the services. So they have some websites like Elipcapcha have limit, like you can have 1 million CAPTCHAs at maximum consumed by your website in one day. And after that, they really do not specify how it goes. So, and there are a lot of other CAPTCHA providers. I have given 3 here. One is CAPTCHAs.net, one is CAPTCHA, and the third one is Recaptcha to the right. So this is how typically a CAPTCHA provider integration works. This is a user here, and this is a CAPTCHA provider, and this is a server to which you're going to try and create a new login. So let's see, for example, you want to register for a new mail ID. So you go to the registration page. The next step, you get an HTML back or JSP or what file here, which has an image or a script tag. So what that does is it allows the browser, when the browser reaches that HTML tag, it will retrieve the image, or it will retrieve a JavaScript, which is further going to retrieve images and then show it to you. The next step is the CAPTCHA retrieval process. This goes to the CAPTCHA provider and not this server here. So the CAPTCHA retrieval is independent of this server. So the only thing that this server does is it will provide an image tag, which you will, when you try to load the image, it is going to be from a CAPTCHA provider. And then after you get the image, you solve a CAPTCHA, you send it to the server, and this server in turn forwards it to the CAPTCHA provider. The CAPTCHA provider validates the solution and sends a response back to this server. So this response is typically a Boolean. It doesn't have to be more than that. It says the CAPTCHA is successfully solved or it is failed. And depending on that, your registration is either allowed or it is disallowed. So that is the CAPTCHA provider integration scenario. Does anybody have any questions here on how this really works out? Because this is going to be important when we look at the demonstrations and the attacks on this particular CAPTCHA provider integration technique. All right, let's move ahead. So this is how the retrieval typically works. You have the image and you have the source. This is OpenCAPTCHA, and here when you talk about reCAPTCHA, it is google.com reCAPTCHA API, and then you send the challenge along with that. So this is how the CAPTCHA retrieval works in a typical web page, and this is what gets displayed. So what went wrong? The libraries are insecure. While I was looking at a lot of libraries, for example, let's talk about reCAPTCHA because it is the most popular out there. All of the libraries that do the CAPTCHA validation part were insecure. The CAPTCHA verification was performed over plain text HTTP, and what that allowed you to do is the requests can be intercepted. So for example, if I am in a position to intercept the traffic which is coming at the step 5 here, I can very much control what comes back in step 6, and then I can influence the behavior which is coming at step 7 here. So the requests can be intercepted, and there is a bullet point here which says steal private keys. So reCAPTCHA uses private keys to identify a particular website or a website that consumes its CAPTCHA services. So and it sends these private keys over the plain text HTTP protocol. So if you're able to intercept the communication, you can very much steal the private keys, and you don't really have to be a registered reCAPTCHA user to use the services. So you can take a key, put it on some other website which you own, and then you can use that without even registering for Google services. Then there is a possibility that you can generate response, or you can alter the responses which are coming from the CAPTCHA provider. So let's see how it goes. So this is the CAPTCHA verification libraries. So this is on the top you see, which is from Rails library. This is a code in Ruby, and you can see that the verify URL is HTTP. And there is, if you see, there is no verify URL which is over HTTPS. There is a retrieval URL which is over HTTPS. So the retrieval URL allows you to retrieve a CAPTCHA from a particular website. So this allows you to avoid mixing HTTP and HTTPS, but there is no mechanism with which you can ask reCAPTCHA to validate over HTTP in the default libraries. And similarly with the ASP.NET library, I reversed it and saw that the validation requests were being sent to plain text or over HTTP. So the impersonation part, what we are going to see here is, as I said, if you are able to impersonate and redirect the verification traffic to your server, you can control the entire response, and you can bypass the entire protection, which is the CAPTCHA validation protection. So here is how it goes. Step 1, 2, and 3 complete as we saw earlier. In the step 4, what you see here is that when CAPTCHA solution comes and it goes out for validation, we hijack the traffic, and the validation is in turn performed by the server that we control. And when we control the server, we can choose the response that we want to send back, and based on that we can influence the step 7 and step 6. So if we are able to control 6, we anyway control 7. So this is how the CAPTCHA provider impersonation works. Any questions on this slide? All right. So the tool that we're going to discuss today is Elipcapcha. So what this does is, it is basically, it lifts off SSL strip code base. I believe most of you would be familiar with SSL strip, right? So I modified SSL strip to suit my purpose. It's written in Python because SSL strip was Python. So what it does is, it impersonates CAPTCHA providers. So it allows you to become a CAPTCHA provider. So you can be reCAPTCHA, you can be CAPTCHA, or you can be OpenCAPTCHA, or any CAPTCHA provider you want. with easy configuration files, which comes in the form of XML. Then it administers CAPTCHA verification requests. So you can accept a CAPTCHA verification request, allow it or deny it, or do whatever you want with that. And you can even cause a denial of service for some registrations by denying all the CAPTCHA validation requests. And then you can also record the logs, and you can steal the private keys, which we talked about earlier. So this is how the CAPTCHA verification requests look like. It is an important point to remember that all these requests go over HTTP1. The second important thing is that a combination of the host name and the validation path here are used to identify a unique CAPTCHA provider. So let's say, for example, a request is going to google.com, and it is going to a validation path, which is reCAPTCHA API verify. When Elipcapcha sees these two things in the combination, it will recognize that the request is for reCAPTCHA, and then it will go and analyze the contents of the body. Based on these contents, it will serve a response back to the requesting server. And then this is OpenCAPTCHA specification. So what it allows you to do is, the host name is www.opencaptcha.com. Then the requests are sent to validate.php, and this is the form which is answer is equal to solution and image is equal to CAPTCHA identifier. So this information is used by OpenCAPTCHA to verify the CAPTCHA. And similarly here, for reCAPTCHA, you see that a private key goes, and then there is a remote IP address, then there is a challenge, which is the image identifier, and then there is a response. So Elipcapcha analyzes all of this to come to a conclusion that what should be the response that it should be sending back, what is the CAPTCHA provider, so it identifies that, and based on that it responds to your requests. So these are the type of responses which you typically see when you're validating CAPTCHAs. So for reCAPTCHA, the validating host we saw was google.com. When a CAPTCHA solution is successful, you get a 200 OK. Some CAPTCHA providers give you a 400, 404, or 400 or 401 to indicate that the CAPTCHA solution was incorrect. But reCAPTCHA uses 200. OpenCAPTCHA also does the same. Some CAPTCHA providers rely on response headers. For example, somebody would just add a custom header which would be, say, success, and then it would be like true or false. So that for reCAPTCHA there is no mandatory header, and for OpenCAPTCHA also there is no header that is mandated. Then the success body. So when the CAPTCHA solution is correct, you see that the body would contain just one string which is true, and for OpenCAPTCHA it will contain which is something which is pass. Now when you see a failure, the first two things are same. You get 200 OK, and you also get there is no header again, but the failure body is a little different. So reCAPTCHA returns an error code along with the false message, and OpenCAPTCHA just retains a string which is fail. So some CAPTCHA providers return like say 1 or 0, true or false. So there are a lot of different types of responses that you need to cater to when you write a generic tool like Elipcapcha. So it has to look forward for the signatures when the requests go out, and it has to be able to construct the responses based on each CAPTCHA type. So CAPTCHA verification and request and response characteristics. There is a dedicated server all the time, and it has to abide by HTTP specifications. So that makes writing the tool a little easier. And the responses are true or false, pass or fail, 1 or 0. So they are primarily Boolean. So that helps us write a generic tool that can impersonate any CAPTCHA provider, because the responses are going to be 0 and 1. It is not going to be a content of an email. For example, there is no human interpreting it. So even if there is, let me put it this way. So if there is no human interpreting it, there is no way for the machine to be able to figure out that the person on the other side is a machine or a human. So that is what is the primary trust here, and that's what Elipcapcha exploits. This is how the Elipcapcha help looks like. And there are several operational modes. So there is a monitor mode which allows you to monitor all the CAPTCHA validation requests, log the requests locally, take out the private keys and do more stuff. And there is a denial of service mode, which allows you to send a denial of service or say a false for every CAPTCHA request that you receive. So that effectively terminates the possibility of creation of new accounts or any of those things. So for as long as you are intercepting the traffic and you're sending false for every request, there will be a denial of service. And then there is a stealth mode in which you can provide a custom string. Why this is needed is because, let's say you happen to be able to intercept CAPTCHA validation requests for one website, and then you start approving every CAPTCHA request that you receive. There will be a surge in the amount of account creations, and that may raise red flags. So there is a stealth mode which would, what I would say is approve the CAPTCHA requests only those that you generate. So if I'm an attacker, I can control the CAPTCHA requests that my server would generate, and those requests would belong only to me and not for anybody else. And there is a random mode which would send out randomly true and false responses. This is just a teaser mode. And there is an avalanche mode. Once you initiate this mode, every CAPTCHA request that comes to this to Elipcapcha would be responded with a true. So all the CAPTCHAs get approved. So let's look at the few demonstrations here. All right. So this is a small Rails application that I have written, and it's running on a VMware here. So two VMwares. This is where Elipcapcha is running, and this is where the server is running. Now what I'm going to do is I'm going to show you how these web applications work. So you can enter a new secret here. And if you say some value, can somebody say his or her name? All right, I'll just pick one myself. So if you provide an incorrect CAPTCHA solution, what is going to happen is that value won't be stored in the database. So it's that simple. If you provide a correct solution to the CAPTCHA, you will see the value in the database. So everyone understands this behavior now? So if you solve the CAPTCHA correctly, the value goes into the database and then it persists there. If you don't solve it correctly, you get you just have to enter the value again with a new CAPTCHA. So is that okay? Similarly, this is CAPTCHA again. The same implementation is here for 3 different CAPTCHA providers. We'll test this out if it works well. If I give any random string here, it won't work. Let me provide something more useful. B, Y, 6, and C. All right. All right, so that was submitted, and we have 2 Outerz0ne entries now. Similarly for open CAPTCHA. So we can see it across different CAPTCHAs. Now let's start with the process of intercepting the requests and to be able to modify the responses. So what I'm going to do now is I'm going to configure the VMware or to enable IP forwarding on the Elipcapcha machine. The next thing I'm going to do is I'm going to enable the port forwarding here. So this is IP tables, and I initiate the pre-routing, and then I say for the destination port is 80, and then you have to redirect to port 7777, which is the default port where Elipcapcha works. And then I'm going to initiate ARP spoofing. I'll do that from another. So what? Just give me a minute. I think I'll. Alright, so what this command will do is it will initiate an ARP spoof of on Ethernet 0 interface for all the requests going to from this IP. It'll like ARP poison 137, and it'll create the gateway for this host to this. So let's start this now. So the ARP poisoning takes place, and it says, all right. So the ARP poisoning is effective now. So what we are going to do now is we are going to run Elipcapcha. All right, so these are the various monitor modes: monitor mode, avalanche mode. By default, it runs in a monitor mode. So we're going to just start with that. You can choose the CAPTCHA that you want to intercept. We are going to just first run it in a monitor mode and let it capture the keys for reCAPTCHA, and we will be able to see that. So it is capturing the CAPTCHAs for reCAPTCHA, OpenCAPTCHA, and CAPTCHA, 3 providers. So the monitor mode would allow all the requests to complete as they are. So it would just record the request, and it will just record the request and it will pass it on to the server. So here you will see that we will need to provide a correct solution for us to be able to enter the value into the database. We are going to stop Elipcapcha and look at its log. So you see here that it's today, right now, and it was able to get a private key, which is something we can use and put it on our servers to use the services, reCAPTCHA services, without even registering for it. And then there is a response which we really don't care to know what it is and how it really works out. So this is the monitor mode, where which you can intercept the CAPTCHAs, take the private keys out, and use private keys in your own website without registering for the services. The next mode we are going to start is the avalanche mode. Here you will be able to intercept all requests and approve them no matter what solution you provide. So what I've done is ran it in avalanche mode, which is with the -a flag, and let's see what we see now. Testing. And if I provide a wrong solution, in ideal behavior I should be allowed to enter a new string, but with and the current string will not be stored. So you see, we were able to thank you. So we were able to bypass the protection, and we were able to put the values in the database, and we bypassed reCAPTCHA protection. So let's there is a automated code that I have here. What it is going to do is it's going to submit a large number of requests. Let's see this code here. So these are the URIs to which it will be submitting the requests, and the answer here is Outerz0ne. We will use it later on during the stealth mode, and this is how the requests are going to go out. So let's start it. All right, so you see that the requests are starting to go out, and you see the response body. Let's try to see how it really looks here. Right here. So you see, you're able to bypass the complete CAPTCHA protection, and you can enter as many values into the database as you like. And there are 3 hosts in action here. One, this is the Windows box. These 2 are the VMs. 133 is where the Elipcapcha is running. 137 is where the Rails server is running, and you can see that it is processing the requests, and it is allowing all the requests to enter the data into the database. So that is what the avalanche mode is, where you can have success for every request. Now let's go ahead and look at the stealth mode. All right. So what this stealth mode allows you to do is you can enter the values. It will identify the values which have a particular string and allow only those values. So there is one value which is common across all CAPTCHA providers, which is the solution of the CAPTCHA. So if I am able to provide solution which I know and nobody else knows, I can filter that out from the request and approve the CAPTCHA requests that I send out. So that is what this does. And let's say Outerz0ne. I'm going to run it in stealth mode, and I'm going to approve all the CAPTCHA requests that have Outerz0ne as the solution. So let's look at this code again. So it has Outerz0ne as its string. I'm going to just erase it for a while, and this is the answer where it goes. So you see everything is highlighted in green. Here is the answer, and let's run it one more time. We will see the count here. It's 310031, and then we will start it again. Give it a while. You see it's at the same spot, and there are no additions after this point. This was the previous one, I believe. Yeah, 0030. Now what I'm going to do now is that I'm going to change this to Outerz0ne, and I'm going to run it again. You will see a different response pattern coming back. And if you do a refresh here, you will see that the new requests have started coming into the database. All the ones which have Outerz0ne as an answer for the CAPTCHA are getting approved, and rest everything is getting forwarded to the remote server for validation. Back to the presentation. So this is how you configure Elipcapcha. You have a configuration file. You see a provider. You provide its name. There is host name and path. These two values combined together identify a unique CAPTCHA. So the host name and path, as we discussed earlier, and you tell it how it has to interpret the success. So it will take a response code, it will take a response string and the response body. And similarly for failure, you would do the response code, response string, and the response body. You can also provide headers. There is the syntax for that, and if you download its code, you will be able to see the complete syntax on how the XML file has to look like. And then the recommendations are to perform SSL validation for CAPTCHAs and to make sure that the certificate validation is turned on. Let's look at the configuration file here again one more time. So this is the configuration file. You can have a response body and you can have response headers. You also get config template, which is template.xml. You can provide the header values. So here you see the details. You can provide headers. You can provide name, value. You can add as many headers as you like. If your CAPTCHA provider really is looking for a lot of headers and the library does validation against all of those, you can use all of them here, and the response would be generated based on all the content that you provide here and as per the CAPTCHA provider you have. And you can have multiple lines of responses, line 1, line 2 in the C data, XML C data. So that's about the configuration file. And a special thanks to Moxie for writing SSL strip. That saved me a lot of time. Otherwise, I had to write this from scratch. And I'm open to questions. Any questions? All right. All right, so you can download it from GitHub, and there is a white paper available on. It provides very detailed information on the code and what this tool does and what the attack is. And thank you.